In the silent, unending theatre of space, where distances defy comprehension, our cosmic neighborhood occasionally receives visitors. These are not emissaries from other worlds in gleaming craft, but rather silent, frozen relics from the dawn of other suns. They are interstellar nomads, traversing the blackness for eons, carrying within their icy hearts the chemical secrets of their native star systems. For most of human history, we were blind to their passage. Our sky was a closed system, a familiar tapestry of local wanderers, but recently our eyes have opened. We have begun to spot these travelers from beyond, and one such voyager, a ghost from an unknown hearth, presented us with a riddle so profound, so utterly bizarre, it challenged the very essence of what we thought a comet could be. It was designated 3I Atlas, and it appeared to be firing thrusters at the Sunday. This is not a story of simple observation. It is a cosmic detective case, a tale of physics and philosophy of bafflement and breakthrough. It begins not with a bang, but with a faint, unassuming speck of light captured by the unblinking robotic eyes of the Asteroid Terrestrial Impact Last Alert System, or ATLAS, a sentinel standing guard over our small blue world. In the final days of 2019, data streamed from the Hawaiian mountaintops. Algorithms sifted through the noise of the cosmos, searching for motion for change. And there it was, a faint smudge moving against the fixed backdrop of stars. At first it was just another number, another potential near-Earth object to track, but as astronomers refined its path, a startling reality emerged. This object's trajectory was not a closed loop, an ellipse tethered to our Sunday. Its path was a hyperbola, an open-ended arc screaming through our solar system, destined to return to the interstellar void whence it came. It was only the second such interstellar object ever detected after the enigmatic Oumuamua. Unlike its predecessor, however, this one had a familiar look. It was fuzzy, enveloped in a glowing shroud of gas and dust called a coma. It was unequivocally a comet, but it was a comet like no other. To understand the sheer strangeness of 3I Atlas, we must first journey back in time to our earliest conceptions of these celestial apparitions. For millennia, comets were not objects of scientific inquiry, but portents of doom omens painted across the night sky. They were celestial spectres, the fiery swords of gods, harbingers of plague and the fall of kings. The ancients saw them as atmospheric disturbances, phenomena of our own world like lightning or rainbows, not as citizens of the heavens. This perception held for centuries a testament to our terrestrial confinement. It took the meticulous gaze of a Danish nobleman in the 16th century, Tycho Brahe, to begin to unravel this misconception. Observing a great comet in 1577 from his island observatory, Brahe used the principle of parallax, the apparent shift of an object against a distant background, to measure its distance. He compared his own observations with those made elsewhere in Europe. If the comet were close in our atmosphere, its position against the stars would have shifted dramatically. But it barely moved. The inescapable conclusion was revolutionary. The comet was far beyond the moon. It was a true celestial body journeying through the realm of the planets. The heavens were not static and perfect. They were dynamic and filled with transient wanderers. A century later, Isaac Newton's laws of universal gravitation provided the mathematical language to describe these cosmic journeys. It was his friend and colleague Edmund Halley who applied this new physics with breathtaking vision. Halley meticulously catalogued historical sightings of bright comets, noting a remarkable similarity in the paths of comets seen in 153, 11607 and 1682. He made a bold, almost audacious prediction that these were not three separate objects, but a single comet on a vast elliptical orbit, and it would return again, reappearing in our skies around 1758. Halley did not live to see his prophecy fulfilled, but on Christmas night of that year, a German amateur astronomer spotted the returning Voyager. Halley's comet had arrived right on schedule. It was perhaps the greatest early triumph of rational predictive science. Comets were no longer omens. They were physical objects bound by the same laws that make an apple fall. They were at their core understandable. This understanding solidified in the mid-20th century with the work of Fred Whipple. He proposed the now famous dirty snowball model. Imagine a loose clump of ice, not just water ice but frozen, carbon dioxide, methane, ammonia and carbon monoxide. Mixed into this cosmic ice block are dust, rock and organic molecules, the primordial grit left over from the formation of a star system. This is the comet's nucleus, its solid heart often only a few kilometers across. For most of its existence in the deep freeze, far from any star, it is inert, dark and invisible. But as its orbit carries it into the inner solar system, the story changes dramatically. The gentle warmth of a distant sun begins to reach its surface. The ices exposed to sunlight do not melt into liquid. In the vacuum of space, they sublimate, turning directly from solid to gas. This outgassing erupts from the surface, creating jets of vapor and dust that form a vast glowing atmosphere around the nucleus, the coma. This beautiful shroud can swell to be larger than the planet Jupiter, and as the comet flies onward, this material is swept away by two powerful solar forces. The unrelenting stream of charged particles from the sun, the solar wind, pushes the ionized gas directly away, forming a straight bluish ion tail. Simultaneously, the subtle pressure of sunlight itself, photons striking fine grains, pushes the dust particles away, creating a broader, curved, yellowish dust tail. The rule is simple, elegant, and for centuries inviolable. A comet's tails always point away from the Sunday. It is the fundamental law of cometary anatomy. 3I, Atlas, was about to shatter that law into 7 baffling pieces. As the interstellar visitor drew closer, telescopes across the globe turned to watch. Its journey was a gift. Oumuamua had been a fleeting shadow gone before we could truly study it. But Atlas was a classic comet, bright and active, offering us a chance to perform a chemical autopsy on matter from another star. Then the images began to reveal the anomaly. From the comet's glowing coma, structures were emerging. They were not the familiar sweeping tails pointing away from our star. These were distinct narrow jets of dust like sharp spines or spikes. And they pointed in the wrong direction. One by one, astronomers counted them. 7 distinct jets, 7 feathery appendages fanning out from the nucleus, and they all appeared to be aimed with unnerving precision back toward the Sunday. This was not just unusual, it was by all known models impossible. It was like finding a ship's wake streaming from its bow instead of its stern. The phenomenon was so bizarre, it was dubbed an anti-tail, but even that term failed to capture the sheer strangeness of multiple sharp sunward-pointing features. The fundamental rule was broken. The cosmos was presenting a puzzle that seemed to defy the very physics that governed it. The scientific community scrambled for an explanation. Could our models be wrong? Was there some unknown force at play? The data was undeniable, the images stark and clear. The most outlandish speculation whispered in forums and on the fringes of academic debate was immediate and electrifying. Were these thrusters? Was this object not a natural dirty snowball but something else entirely? An artificial probe disguised as a comet using directed jets of material for propulsion or course correction. This idea, however thrilling, is fraught with peril for a scientist. Extraordinary claims require extraordinary evidence. And yet the ghost of Oumuamua lingered in everyone's mind. That first interstellar visitor had also defied easy explanation. It was elongated, tumbling strangely, and most perplexingly, it accelerated away from the sun slightly faster than gravity alone could explain. There was no visible outgassing, no cometary tail to account for this extra push. This led some, most notably Harvard astronomer Avi Loeb, to propose that it could be an artifact of an extraterrestrial civilization, perhaps a solar sail, thin and light, pushed by the pressure of sunlight. The idea was met with immense skepticism, but the mystery of Oumuamua's acceleration was never fully resolved. Now here was the second interstellar visitor, 3I, Atlas, and it too was exhibiting a bizarre propulsive-like behavior. Except this time the thrusters were in plain sight. 7 of them, pointing at the Sunday. Was this a pattern? Were the messengers from distant stars trying to tell us something? Or was nature simply more inventive, more wonderfully strange than our models had allowed for? To solve this riddle, we need to abandon the simple image of a comet as a uniform, gently fizzing snowball. We must envision a far more chaotic and complex object. Imagine a large, misshapen potato several kilometers long, This is our comet's nucleus. It is not spinning smoothly like a planet. It is tumbling erratically through space, a relic of ancient violent collisions. Its surface is not a clean sheet of ice. It is a rugged, cratered landscape of dark, insulating dust and exposed patches of highly volatile primordial ice. Now, place this tumbling, chaotic object in the heat of the Sunday. As it rotates, different regions are exposed to direct sunlight. A patch of exposed ice, perhaps at the bottom of a crater, is suddenly flash-heated. The frozen gases beneath the surface sublimate violently. The pressure builds until it erupts in a powerful focused jet like a geyser. This jet is a natural rocket engine. According to Newton's third law, for every action there is an equal and opposite reaction. The plume of gas and dust shooting out in one direction gives the entire nucleus a gentle but persistent push in the opposite direction. These are non-gravitational forces, the very same forces suspected of pushing Oumuamua. In the case of Atlas, the outgassing was so powerful, the jets so distinct, that they created the illusion of deliberate thrusters. But this only explains the existence of jets. It does not explain why they appeared to point toward the Sunday. The solution to that part of the puzzle lies in a clever trick of geometry and perspective. Think of a spinning lawn sprinkler on a hot summer day. The water shoots out in fine streams propelled by the pressure from the hose. The sprinkler head itself rotates, casting arcs of water across the grass. Now imagine you are looking at this sprinkler from a great distance from above. The water droplets, once they leave the nozzle, are no longer being pushed. They are simply coasting, following their own path, determined by momentum and gravity. The heaviest droplets don't travel as far and fall to the ground quickly close to the sprinkler. The finest mist, however, is so light that a gentle breeze can pick it up and carry it in a completely different direction. A comet's dust is similar. The jets spew out a mixture of particles, from fine, smoke-like grains to larger sand-like pebbles. The solar wind and radiation pressure are the breeze. They are very effective at pushing the lightest, smallest dust particles away from the sun, forming the traditional magnificent dust tail. But the larger particles, the pebbles and heavier grains, are too massive. The feeble pressure of sunlight can barely nudge them. Once ejected from a jet, these heavy particles are essentially abandoned by the comet. They are left to drift in space, continuing along the comet's original orbital path, like a trail of breadcrumbs marking where the comet has been. From our vantage point on Earth, we are looking at the comet from a particular angle. We see the nucleus, the coma, and the true tail being blown away by the Sunday, but we also see this long, curving trail of abandoned heavy dust stretching out behind the comet along its orbit. Depending on the geometry of our viewing angle, this trail of debris can appear to be pointing in a different direction. Under just the right circumstances, this orbital trail can appear to be pointed back towards the Sunday. This optical illusion is what astronomers call an anti-tail. It's not really a tail at all, but a fan of debris left in the comet's wake. So the mystery of 3I, Atlas, can be solved by combining these two phenomena. The thrusters were real, but they were natural. They were powerful, localized jets of sublimating gas erupting from a rapidly rotating, chaotic nucleus. The anti-tails, the sunward-pointing spikes, were a line-of-sight illusion. They were the trails of heavy dust ejected by those very same jets spread out along the comet's orbital path and viewed from just the right angle to make them look like they were aimed at our star. It was not an alien craft. It was a natural freak, a perfect storm of cometary physics. The nucleus was spinning incredibly fast, completing a rotation in just over 5 hours. This rapid spin acted like a centrifuge, helping to fling material away from the surface. Furthermore, as it approached the sun, the heating became so intense that the entire nucleus began to break apart. The thrusters were not just jets, they were the signs of a body in its death throes. 3I, Atlas, was disintegrating before our very eyes, releasing the ancient frozen material it had carried across interstellar space for millions of years. The conclusion that 3I, Atlas, was a natural, albeit bizarre object does not diminish its profound importance. In fact, it enhances it. It provides a stunning window into the sheer diversity of objects that the cosmos can produce. It tells us that comets in other star systems can be dramatically different from our own. Perhaps they are born with faster spins. Perhaps their chemical makeup leads to more violent outgassing. This single object has enriched our understanding of planet formation across the galaxy. The light from its disintegrating fragments was captured by our most powerful spectrographs. These instruments act like prisms, breaking down the light into its constituent colors, a rainbow barcode that reveals the chemical elements present in the material. By studying this light, we can determine what 3I, Atlas, was made of. We are analyzing the building blocks of a solar system that is not our own. We are reading a chemical postcard sent from an unknown star. This is the true deep value of these interstellar visitors. They are physical samples delivered to our doorstep from distant corners of the Milky Way. The story of 3I, Atlas, also serves as a crucial lesson in the practice of science. It is a process of eliminating the impossible to find the truth, no matter how mundane that truth may initially seem compared to fevered speculation. The thruster hypothesis was exciting, tapping into our deepest hopes and fears about our place in the universe. But science demands rigor. It demands that we first exhaust all known natural explanations. The solution involving a rapidly spinning nucleus, powerful jets, and a perspective illusion is a masterpiece of celestial mechanics and physics. It is a testament to the power of our models to explain even the most baffling phenomena. It shows that the universe, without any need for intelligence or intervention, can produce sights that appear to our pattern-seeking brains entirely artificial. And this is a humbling and awe-inspiring realization. Nature's capacity for complexity and surprise far exceeds our own imagination. The era of interstellar visitors is only just beginning. For all of history, we were lucky to spot one, Oumuamua and 3I, Atlas, arriving within just a few years of each other, were not a coincidence. They were the first drops of an impending rainstorm, our surveillance of the skies becoming exponentially more powerful. Soon the Vera C. Rubin Observatory in Chile will come online. This monumental instrument will survey the entire visible sky every few nights, generating an unprecedented flood of data about our dynamic universe. It is expected to discover not one or two interstellar objects, but dozens, perhaps hundreds every year. We are about to open the gates to a zoo of interstellar wonders. We will find more comets like Atlas, more strange asteroids like Oumuamua. We will undoubtedly find objects that are stranger still, new classes of celestial bodies we have never before conceived of. Each one will be a puzzle. Each one will carry a piece of the galactic story, and with this new capability comes a tantalizing future prospect interception. We have sent probes to our own solar system's comets. The European Space Agency's Rosetta mission orbited and landed on Comet 67P, a breathtaking feat of engineering. Could we do the same for an interstellar visitor? The challenge is immense. These objects are moving incredibly fast, and they give us very little warning of their arrival. Designing a mission to chase down, rendezvous with, and study one of these nomads would require a spacecraft faster than anything we have ever built, and a level of readiness that is currently beyond us. But projects like the European Space Agency's Comet Interceptor are already being designed. The plan is to have a probe waiting in space, dormant, ready to be directed toward a suitable long-period comet, or ideally an interstellar object once one is found on the right trajectory. Imagine that moment, receiving the first close-up images of an object born in the nebula of another star, analyzing its ice not from afar through the distortion of a coma, but by scooping up a physical sample and testing it in an onboard laboratory. Would we find chemistries completely alien to our own isotopes in ratios that tell of a different, more violent stellar history? Or would we find that the building blocks of life, the amino acids and organic compounds, are common everywhere, sprinkled throughout the galaxy like seeds on the wind? These are the questions that drive us forward. The ultimate fate of 3I, Atlas, was one of cosmic dissolution. The celestial nomad, after a journey of perhaps millions of years through the cold and dark, could not survive its brief, violent encounter with our Sunday. It broke into countless smaller fragments, its substance scattered into a diffuse cloud of dust and gas. Its message, once contained in a single solid body, is now written in a trail of dissipating particles, a ghost of a ghost slowly fading back into the fabric of the solar system. But its legacy is indelible. It forced us to refine our understanding of comets. It demonstrated the beautiful complexity that can arise from simple physical laws. and it served as a dress rehearsal for the mysteries to come. The 7 anti-tails of 3I, Atlas, were a spectacular cosmic illusion, a magic trick performed with light, dust, and perspective. But like any good trick, its power lies not in deception but in making us question what we believe to be real. It reminds us that the universe is not obligated to conform to our expectations. Its landscapes are sculpted by forces we are only beginning to grasp. Its creations are more varied, its behaviors more exotic than we can predict. We stand on the shore of a cosmic ocean, and the first few pieces of driftwood from other islands have just washed ashore. One was a strange, inert sliver of rock or ice. The next was a hyperactive, self-destructing snowball that appeared to defy physics. What will the third one be? The question hangs in the star-dusted blackness, a profound and thrilling unknown. For now, the verdict on 3I, Atlas, is in it was a natural freak, not an alien machine. But in solving this one riddle, we have unlocked a dozen more questions. We have been reminded that in the grand, silent theatre of space, the most spectacular shows are often the result of nature's own boundless ingenuity. And our role is simply to watch, to wonder, and to try with all our might to understand the next visitor that emerges from the interstellar darkness. The sky is no longer a closed book, its pages are turning, and we are finally, after all this time, learning how to read them.